Hans Geiger was known as the person who invented the Geiger counter. While he was known for that, he was also known for a few other things. In 1912, Hans Geiger was appointed head of the Germany National Institute of Science and Technology in Berlin. In 1914, Hans Geiger participated in World War One, serving in German field artillery. And then in 1945, Hans Geiger participated in Germany's attempt to create an atomic bomb during World War Two. He participated that briefly before he fled Germany and then died. While he was known for those things, he's also known for helping out in the discovery of the nucleus, which was done by himself, Ernest Rutherford, and Ernest Marsden. Uh, this discovery came across in May 1911 in Manchester, England. Marsden was the first who came across this discovery in an experiment serving under Rutherford's and Geiger's coalition as their student at the time. During the experiment, Marsden was performing an alpha particle experiment, which was where he had a sample of radium, which would fire or emit alpha particles at a thin gold sheet. As Marsden was observing this, he observed that the particles fired off or scattered at a greater angle than what was expected at that time. After that, Rutherford and Geiger performed more experiments to come to the conclusion that seeing that the plum pudding model at the time of the atom was incorrect, and that an atom, most of its center, that its center would hold most of the mass there. This would be called the atomic nucleus, or nucleus for short. This discovery proved that basically an atom, the center of it was where all the matter was, and that it was held into a vacuum sealed state. It also disproved Rutherford's previous plum pudding model of the atom, and then influenced Neil Bohr to make one of the first iterations of the Bohr model, which would soon become, after some alterations, would soon become the current Bohr model that is used today. Another discovery within the atomic theory was the discovery of alphas and betas, which was done by Ernest Rutherford in 1999 in Cambridge, England. Rutherford at the time was experimenting with samples of radium enclosed around basically a lead box with a hole in it. With this hole, and as the uranium decayed, Rutherford would observe what would be coming out the hole as rays or particles or what else. But as the uranium decayed, Rutherford came across the discovery of alpha and beta particles, which seemed to be similar to Röntgen rays at the time. After this, Rutherford would conclude that these what were similar to be Röntgen rays would be alpha and beta rays. However, alphas and betas would not be considered as particles until alpha particles would be considered alpha particles in 1902, and beta particles would be considered beta particles in 1899. However, this initial discovery, brought along what was the existence of alpha and beta particles into existence, even though they weren't considered particles at the time. This discovery helped science in many ways because it showed how many experiments can be used by observing the decay of these alpha and beta particles, as well as how they can use these alpha and beta particles within experiments to what would soon be discovery of the nucleus and other discoveries within the atomic theory. The discovery itself also showed the different paths of decay that a radioactive substance can take. Many of these discoveries brought many influential times within atomic theory. However, one of the most influential, in my opinion, will be the discovery of the atomic nucleus. Within this, many scientists used different experiments to dissect and see what this atomic nucleus was, what they could change about it, what alpha beta particles would decay from it, what alpha and beta particles could do to it, and basically what anything could do to it. It brought along a new era of what was the atom.